Yes friends, welcome once again to the class and welcome once again to the channel. And today we are going to learn about alpha decay. In the previous lecture I had introduced you to the nuclear decay. Okay, I had introduced you to nuclear decay in the previous lecture. But in this particular lecture we will start with alpha decay. What is alpha decay and all those things we are going to learn in the present lecture. In the next lecture we are going to learn about Gamo's theory of alpha decay, but at present we are learning about alpha decay introduction. Okay, introduction to alpha decay. If you are new to the channel, then certainly you can go to the link in the description and start watching from the very first lecture of nuclear and particle physics. Then from that very first lecture of nuclear and particle physics, there is a link in the description. There is a link in the description. If you click on that link, it will redirect you to the playlist of nuclear and particle physics for UPSC CSE physics optional. So you can watch it from the very first lecture. You can watch it from the very first lecture. So alpha decay. Okay, let's learn about alpha decay. So what is alpha particle, by the way? What does it mean by alpha particle? So alpha particle is a nucleus of helium atom. Okay, what does it mean by helium atom? Now let us understand what is helium atom. So helium atom looks something like this. Okay, helium atom looks something like this. There are two protons and two neutrons in the nucleus, and there are two electrons in the outer shell. In the outer shell, two electrons. Okay, two electrons are revolving. According to Rutherford model, the nucleus contains two protons and two neutrons, and the two electrons are revolving in circular orbit around the nucleus. Two electrons are revolving in circular orbit around the nucleus. This is what is meant by uh, your. This is what is told by Rutherford model. But according to quantum mechanics, according to quantum physics or quantum mechanics, what is the case? According to quantum physics or quantum mechanics, the thing is that these two electrons are not actually revolving around the nucleus. According to quantum physics, these two electrons are not actually revolving around the nucleus. They are actually in the form of a electron cloud. Okay, these two electrons, they are not revolving around the nucleus. They are in the form of electron cloud. Why it is wrong to say that they are not revolving around the nucleus? Why it is wrong to say that they are not revolving? Why it is wrong to say that they are revolving around the nucleus? Why is it wrong to say that these two electrons are revolving around the nucleus? Why is it wrong to say so? It is wrong to say so because according to quantum physics, we cannot draw trajectory of electron. Okay, electron is a microparticle. Electron is a microparticle because mass of electron is what? Mass of electron is 9.1 into 10 to the power minus 31 kg. This is the mass of electron. Now for such smaller masses, this is a very small mass indeed. This is a very small mass. Now for such smaller masses, it is not possible to draw sharp trajectory. Okay, it is not possible to draw sharp trajectory. So the fact that electrons are revolving around the nucleus is wrong, because according to Heisenberg's uncertainty principle, we already know that electrons, any microparticle, if we have any microparticle, its trajectory cannot be drawn. According to Heisenberg's uncertainty principle and quantum physics, we already know this, that any microparticle is there. If we have any microparticle, then its trajectory cannot be drawn. Okay, according to quantum physics and Heisenberg's uncertainty principle. But according to Rutherford's model, we have these two electrons which are revolving around this nucleus, and this nucleus is consisting of two protons and two neutrons. And this is what? This is He24 He24 atom. This is what? He24 atom. Okay, this is He24 atom. Now if we give the ionization energy, if we give energy to this particular electron, and if we give energy to this particular electron, then what will happen? If you give energies to those two electrons, what will happen? They will jump out. These two electrons, they will jump out. Okay, these two electrons will jump out if you give sufficient energy. Then those two electrons will jump out, and you will be left with a nucleus consisting of two protons and two neutrons. you will be left with a nucleus consisting of 2 protons and 2 neutrons. Now this particular nucleus, which consists of 2 protons and 2 neutrons, this particular nucleus is what? This particular nucleus is alpha particle. This particular nucleus is alpha particle. Okay, so such is the thing. Now alpha particle, that means He24, that is nucleus of He24 atom, and He24 atom, when 2 electrons are ejected, from He24 atom, what happens? It gives you an alpha particle. As already discussed over here. 2 electrons ejected, so alpha particle we got alpha particle after ejecting 2 electrons. And when 2 electrons were there, when 2 electrons were revolving, at that time we called it atom. When 2 electrons were revolving, we called it atom. But as soon as 2 electrons are removed, so we are left with only nucleus. And that nucleus is alpha particle. So in short, alpha particle is what? Alpha particle is helium He24 nucleus. Okay, He24 nucleus. This is what is meant by alpha particle. He24 nucleus. That is what is meant by alpha particle. Okay. Now, alpha decay occurs in all nuclei with atomic mass number A greater than 210. Okay. So atomic mass number A greater than 210. What does it mean? What does it mean by atomic mass number A greater than 210? So atomic mass number A greater than 210 simply means that number of protons plus number of neutrons. Number of protons plus number of neutrons is equal to what? Is equal to atomic mass number A. Number of protons plus number of neutrons is what? Atomic mass number A, which is total number of nucleons. What is it? Total number of nucleons. Okay. Now when total number of nucleons is greater than 210, when it is greater than 210, then what happens? So alpha decay occurs in all nuclei with atomic mass number A greater than 210. So when the atomic mass number A is greater than 210, then alpha decay actually occurs. Okay. Since R equal to R naught a to the power 1 by 3, this particular formula, R equal to R naught a to the power 1 by 3, this particular formula, this is what? This is your formula for spherical nuclei. This is what? This is formula for spherical nuclei. But we generally use it, although it is not an appropriate formula, means it is an approximation. Because all the nuclei are not spherical. It is an approximation. Why? Because all the nuclei are not spherical. Let me tell you a particular fact. Okay, all the nuclei are not spherical. Some are oblate and prolate. Also. Okay, so some nuclei are also oblate and prolate. Some nuclei are spherical, but all are not. Okay, so means majority of nuclei are spherical actually. Majority of nuclei are spherical. Okay, so all nuclei are not spherical. Some are oblate and prolate also, but majority are spherical. Majority of nuclei are spherical. But majority are spherical. Okay, so oblate. What is oblate shape? Oblate shape is something like this. Okay, and what is prolate shape? Prolate shape is something like this. Okay, this is oblate shape and this is prolate shape. And what is this spherical shape? Spherical shape is like this. You already know. Spherical shape although it is looking like a circle, but you have to imagine it in 3D. Okay, like a ball, this is what, this is spherical. So you just imagine it in 3D, so just imagine it to be a ball which is coming out of your screen and going inside the screen. Okay, so this particular part is on the screen, this particular part is also going inside the screen and also coming outside the screen. Okay, this particular shape also you have to imagine it in 3D, this particular oblate shape also you have to imagine it in 3D. Okay, so it is also going inside the plane and also coming outside the plane, so it is a 3D object. Similarly, prolate shape, this also you have to imagine in 3D, it is also going inside the plane and it is also coming outside the plane. Okay, so the plane is the screen of your device, and some part of it is going out of, means inside your screen, some part is going inside your screen and some part is coming outside the screen. Okay, so we have a limitation, on 2D, we have a limitation of 2D with us because we are teaching on the blackboard. Okay, I am teaching on the blackboard, that's why we have limitation of 2-dimensional drawing. We cannot draw 3-dimensional drawing because we are teaching on blackboard. Okay, so we cannot draw 3-dimensional drawing. So alpha decay occurs in all nuclei with atomic mass number A. This is what? Atomic mass number. Okay, this is atomic mass number. So atomic mass number A greater than 210. So alpha decay occurs in all nuclei. So alpha decay occurs in all nuclei with atomic mass number A greater than 210. Since R equal to R naught A to the power 1 by 3, which is an approximate formula, this particular formula R equal to R naught A to the power 1 by 3, this particular formula is approximate formula. This is approximate formula. Okay. So heavier nuclei are of larger size. Okay. As R equal to R naught A to the power 1 by 3, so heavier nuclei are of larger size. So clearly, as R, that is radius of the nucleus. R is what? R is radius of the nucleus, right? R is what? R is radius of the nucleus. Okay. Now radius, you can clearly see that radius of the nucleus is directly proportional to atomic mass number A to the power 1 by 3. Radius of the nucleus is directly proportional to atomic mass number A to the power 1 by 3. That is the cube root. This is what? A to the power 1 by 3 means cube root of atomic mass number A. Cube root of atomic mass number A. Okay. Since R equal to R naught A to the power 1 by 3, so heavier nuclei are of larger size. Clearly, for heavier nuclei, the value of A will be larger. For heavier nuclei, the value of A will be larger. So the value of R will also be larger. Okay. Heavier nuclei have higher value of A. So the value of R will also be higher. So let us write over here heavier nuclei. Okay. Heavier nuclei. Heavier nuclei means what? A value is higher. Heavier nuclei means A value is higher. Then R is directly proportional to A to the power 1 by 3. We already know, right? And R is what? R is radius of the nucleus. R is radius of the nucleus. R is directly proportional to A to the power 1 by 3. That implies what? As A will increase, so R will also increase. Okay. So we can also write it like this. We can also write it like this. Okay. So you have already learned in lower classes, right? You have already learned that this particular whenever we write A to the, suppose we write, let me erase all this stuff. Suppose we write A to the power 1 by 2. We write A to the power 1 by 3. So what does it mean? It means that we are taking square root of A. A to the power 1 by 2 means square root of A. And A to the power 1 by 3 means cube root of A. Right? We have already learned. And A to the power 1, what does it mean? A to the power 1 by 1, what does it mean? A to the power 1 by 1 means A to the power 1. And that is your A. Okay. What does it mean by A to the power 1 by 4? A to the power 1 by 4 simply means that we are taking fourth root of A. Okay, and so on and so forth. So A to the power 1 by n, in short, A to the power 1 by n is nth root of A. This you have already learnt in lower classes. I just brushed up the concepts. I have just brushed up your concepts. Since r equal to r naught a to the power 1 by 3, so heavier nuclei are of larger size. So the nuclei which are heavier, they are what? They are of larger size. Okay. Nuclear force is short range, but Colombian force between protons is a long range force. Now let me tell you one fact, that nuclear force is a short range force. Okay. Now let me tell you one particular fact, that nuclear force is significant only if the distance between the nucleons is of the order of 10 to the power minus 15 meter. What does it mean? What does it mean? So let us see. Suppose this particular nucleon is there with us, and we have another nucleon. Okay, we have another nucleon also with us, and suppose the distance between these two nuclei is 10 to the power minus 7 meter. Suppose this much is the distance between these two nucleons. Then will the nuclear force act? Nuclear force, will it act? Will the nuclear force act between these? So the answer is no. The nuclear force will not act between these two. Nuclear force will not act. But will the Colombian force act? Will the Colombian force act? So Colombian force will act. Yes, Colombian force will act. Okay. But if we reduce the distance, between these two, and we make the distance, suppose 10 to the power minus 13 meter, so will nuclear force act? Will it act? The answer is again no. Will the Colombian act? Will the Colombian force act? The answer is yes. Okay. Now if we further reduce the distance between these two nucleons, we are further reducing it, and suppose the distance is 10 to the power, okay, now distance is now 10 to the power minus 15 meter. So will the nuclear force act? Nuclear force will act, yes. Will the Colombian force act? Will the Colombian force act? So the answer is again yes. Okay, Colombian force will also act. Okay. Now if we make the distance very large, suppose we make the distance which is visible with naked eye, we make the distance so huge, that it is visible with naked eye. Suppose we make the distance 1 meter. Okay, so will the nuclear force act? Answer is no. Will the Colombian force act? So the answer is yes. Colombian force will still act, but the nuclear force will not act. Okay. So when the distance is reduced to such an extent, when the distance between the two nucleons is reduced to such an extent that it is of the order of 10 to the power minus 15 meter, when the distance between two nucleons is reduced to such an extent that it is of the order of 10 to the power minus 15 meter, then what happens? Then in that particular case, nuclear force begins to act. Okay, so nuclear force in that case begins to act. Now nuclear force begins to act. What does it mean? Nuclear force begins to act. What does it mean? It means nuclear force will be dominating force. Okay. In all these cases, it will be nil. Okay. Nuclear force will not exist. Negligible. Almost nil, we can say. In all these cases, other cases where the distance is not 10 to the power minus 15 meter. When the distance is not 10 to the power minus 15 meter, in all those cases the nuclear force will be negligible. Okay, it will be almost nil. But as soon as the distance approaches 10 to the power minus 15 meter, we keep on reducing the distance. We keep on reducing the distance between the nucleons till we reach 10 to the power minus 15 meter. Then nuclear force will begin to act, and it will be dominating force. Okay, let me tell you that it will be dominating force. Nuclear force will be dominating force, and this will be dormant force. The Coulombian force will become dormant. Coulombian force will become dormant. Okay. Coulombian force will become dormant in that case. Okay. So nuclear force will become dominating. Okay. Nuclear force will become dominating, and Coulombian force will become dormant at such smaller distances. Nuclear force will become dominating force, and Coulombian force will become dormant force. Dormant means, what does it mean by dormant? Dormant means it will recede in the background. Okay. Nuclear force will be dominating force, so Coulombian force will be dormant force. This simply means that the Coulombian force will go in the background. Okay. Now tell me, two protons are there. We have two protons with us. Now what happens? These two protons will face electrostatic repulsion. That is Coulombian repulsion. Electrostatic repulsion means Coulombian repulsion. Now, no matter what is the distance, okay, no matter whatever is the distance between these two protons, Coulombian force repulsion will always act. It will always act. But we kept reducing the distance. And we made the distance of the order of 10 to the power minus 15 meter. We kept reducing the distance, and we made the distance 10 to the power minus 15 meter. We made the distance to be of the order of 10 to the power minus 15 meter. Okay. We made the distance to be of the order of 10 to the power minus 15 meter. Then what happens? Suddenly nuclear force becomes the dominating factor. Now nuclear force is what? Nuclear force is attractive force. Okay. Nuclear force is attractive force. Now as nuclear force is attractive force, so the two protons will attract each other. Okay. Because the Coulombian repulsion is now in the background. Coulombian repulsion, where did it go? It is dormant, means in the background. Coulombian repulsion is in background. Okay. Coulombian repulsion is in background, and nuclear force is what? Nuclear force is attractive. Okay. Nuclear force is attractive. So that's why two protons. This is the reason. Okay. This is the reason this is the reason why, this is the reason why two protons even after having similar charges, this is the reason why two protons even after having similar charges are bound in nucleus, and do not break apart. Okay, and the are bound in the nucleus, and the nucleus does not break apart, Okay, so this is the reason why even after having similar charges, you already know that like charges repel each other. Still the protons reside inside the nucleus. Like charges repel each other, still the protons reside inside the nucleus. The reason is nuclear force. Nuclear force attracts the two protons. Okay, because the distance inside the nucleus is of the order of 10 to the power minus 15 meter. So that's why the two protons attract each other. Right? So let us see. Nuclear force is short range, but Coulombian force between protons is a long range force. So nuclear force is a short range force, but Coulombian force between protons is a long range force. Now what does it mean by that? Okay, nuclear force. Why short? It is called short range. Why called as short range force? Why the nuclear force is called as short range force? Why called as short range force? So the reason is very simple. Why nuclear force is called as short range force? The reason is very simple. Because it only acts at a minimum distance, at a distance of 10 to the power minus 15 meter or less. Okay, so nuclear force, why is it called as short range force? So nuclear force is called as short range force because it only acts at a distance of 10 to the power minus 15 meter or less. Okay, so it only acts at a distance of 10 to the power minus 15 meter or less. Okay, that's why it is called as short range force. Okay, because it only acts at a distance of 10 to the power minus 15 or less. Okay, now Coulombian force on the other hand. Okay, why is Coulombian force long range force? Coulombian force, why is it long range force? Why is it long range force? So Coulombian force is long range force because it has no limits. It has no minimum. So Coulombian force is called as long range force because it has no minimum or maximum limit. Okay, so Coulombian force has no minimum or maximum limit. Colombian force has no minimum or maximum limit. So that's why it is called as long range force. Okay, that's why called as long range force. Even at set infinity distance. Okay, if we increase, suppose we increase the distance between two protons such that, suppose these are two protons and the distance between them is 1 meter. The distance between these two protons is 1 meter. Now 1 meter is very huge. Okay, 1 meter is very huge as compared to proton size. Very huge as compared to micro object. 1 meter is very huge as compared to micro object. So what does it mean? What does it mean? Very huge as compared to micro object. Still Colombian force will act. Still Colombian force will act between these two protons. Still Colombian force will act. Still Colombian force will act between these two protons. This particular proton and this particular proton. So the Colombian force will still act between these two protons. Okay. So this is the thing. So alpha decay occurs in all nuclei with A greater than 210, R equal to R naught A to the power 1 by 3. So heavier nuclei are of larger size. Nuclear force is short range, but Colombian force between protons is a long range force. Okay, already told to you. So Colombian repulsion overcomes the nuclear attractive force and nucleus breaks. Now what does it mean? Okay, what does it mean by Colombian repulsion force overcomes the nuclear attractive force and the nucleus breaks? Let us understand the meaning of this. Okay, when the nucleus is small, suppose we have, this is the size of nucleus. Okay, this is suppose the size of nucleus. This is proton, this is proton, this is neutron, and this is neutron. This is what? This is light nucleus. This is what? Lighter nucleus. This is lighter nucleus. And let us take one heavy nucleus. Let us take one very heavy nucleus. Okay, this is what? Heavy nucleus. Okay, now in this heavy nucleus, now let me make this very clear to you that this red particle denotes protons. These red particles denote proton. These red particles denote proton. And this blue particle denote neutron. Okay, so red particles denote proton and blue particles denote neutron. This is the case. Now this is heavy nucleus. So this is the proton which we have with us. This is the proton which we have with us. This is the proton which we have with us. This is the proton which we have with us. This is again one proton which we have with us. This is again one proton which we have with us. Okay, this is one more proton. 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 This is one more proton, and this is one more proton. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 protons we have. Okay, and similarly we will have neutrons also, right? Similarly we will have neutrons also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Okay, so this is the thing which we have with us. Okay, now in this lighter nucleus, this is very small. Lighter nucleus is what? It is very small. So lighter nucleus is very small. So 10 to the power minus 15 meter. Okay. Now lighter nucleus means what? Lighter nucleus means atomic mass number A is low. Lighter nucleus means atomic mass number A is low. Lighter nucleus means atomic mass number is low. So what does it mean? It means radius is low. It means radius is small. Okay. So as the radius is small in lighter nucleus, in lighter nucleus, easy to maintain. Ten to the power minus 15 meter order. In lighter nucleus, it is easy to maintain. In lighter nucleus, it is easy to maintain 10 to the power minus 15 meter order radius, distance, okay, between nucleons. So, in lighter nucleus, distance between this proton and this proton, okay, neutron has no charge, right? Neutron has no charge, so it will not undergo repulsion, Coulombic repulsion. Neutron has no charge, so it will not undergo Coulombic repulsion, because neutron has no charge. As neutron has no charge, so it will not undergo Coulombic repulsion. But what about proton? This particular red colored proton, and this particular red colored proton, okay, they reside in lighter nucleus. So as they reside in lighter nucleus, so it is easy to maintain 10 to the power minus 15 meter distance. Distance of the order of 10 to the power minus 15 meter is easy to be maintained. So always the nuclear force will dominate the Coulombian repulsion between protons. In lighter nuclei, the Coulombian repulsion will be very less. It will be there, but nuclear force will dominate. As the distance 10 to the power minus 15 meter, is being maintained. So that's why protons in a lighter nucleus, will face the Coulombic repulsion, but it will not be dominating. Okay, they will attract each other. The protons will attract each other on account of nuclear force, because nuclear force will be dominating factor in lighter nuclei. But what about heavy nucleus? Let us see. What about heavy nucleus? So even after having repulsive force of Coulombian nature, still they will attract each other because of nuclear force. Okay, even after having Coulombian repulsion, they will attract each other on account of nuclear force, and nuclear force is dominating here. Nuclear force over here is dominating factor. So the Coulombian repulsion will be in the background. So because of this nuclear force attraction, the two protons will bind each other. They will attract each other. Okay. Now let us talk about heavy nucleus. And I am taking this proton. We are talking about heavy nucleus, and I am taking this particular proton and this particular proton, which are very much far separated from each other. Now this is heavy nucleus. Means what? Heavy nucleus means atomic mass number A value higher, and atomic mass number A value higher means what? Radius is higher. It means radius is higher. Now if we talk about this particular proton and this particular proton, which are on the edges, okay, they are on the edges. Okay, so it is not easy to maintain from here till here. If we talk about the distance from here till here, okay, distance from here till here, what is it? So distance from there till there, it is actually, sometimes it becomes greater than 10 to the power minus 15 meter. Okay, it becomes greater than 10 to the power minus 15 meter. Okay, as it becomes greater than 10 to the power minus 15 meter, so what happens? So the nuclear force is less now. The Coulombian force begins to dominate, especially between the protons on the edges. Especially when the protons are on the edges. Then what happens? The Coulombian repulsion begins to dominate, because nuclear force is short range. Okay, so the distance has increased now. So the nuclear force is going in the background. Nuclear force has reduced. So the nuclear force which will bind the protons together it has reduced, and the Colombian repulsion is dominating now. So this is what leads to decay. This is the fact which leads to decay, nuclear decay. This is the fact which leads to nuclear decay. Okay, so this is what has been explained over here. So Colombian repulsion overcomes the nuclear attractive force. Okay, nuclear range is short range, nuclear force is short range, and Colombian force between proton is long range force. So Colombian repulsion overcomes the nuclear attractive force. So you can clearly see that in this particular case, the Colombian force overcomes the nuclear attractive force, because the Colombian repulsion will overcome the nuclear attractive force as the protons are getting far away. And why are the protons getting far away? Protons are getting far away because of heavy nucleus, because of larger radius. Because of heavy nucleus, the protons are getting away from each other. Okay. So Colombian repulsion overcomes the nuclear attractive force. So what happens? Colombian repulsion between this and this overcomes the nuclear attraction. Okay. And the nucleus breaks. So Colombian repulsion overcomes the nuclear attractive force, and the nucleus then breaks. Okay. And the nucleus, what happens to the nucleus? The nucleus breaks. Okay. So when atomic mass number A value, that is this total number. Okay. If we begin to count this number 1, 2, 3, 4, 5, 6, 7, 8, 9, we keep on counting the nucleons, suppose. So when we reach the number 210, that is 210 number of nucleons. 210 number of nucleons means what? 210 number of nucleons means atomic mass number A equal to 210. 210 number of nucleons means atomic mass number A equal to 210. Okay. So when we reach the number 210 like this is 10, this is 11, this is 12. So when we reach the number 210 like this, what happens? Then this distance is very far apart. This particular distance in that case is very much far apart. So the Colombian force of repulsion between the protons begins to dominate a little bit, starts to dominate. Colombian force of repulsion between the protons, it begins to dominate. It begins to show its effect because the nuclear force is reducing. Okay. So Colombian repulsion overcomes the nuclear attractive force. So what happens? Colombian repulsion overcomes the nuclear attractive force and the nucleus breaks. So the Colombian repulsion overcomes the nuclear attractive force and the nucleus breaks as soon as we reach atomic mass number A greater than 210. Okay. By emitting the alpha particle, the nucleus decreases its mass number A to move towards stability. So what happens? It emits an alpha particle. What is the meaning of alpha particle? I have already told to you. Okay. What is the meaning of alpha particle? I have already told to you. So by emitting the alpha particle, the nucleus decreases its mass number A. So it will emit an alpha particle and it will decrease its mass number A. Okay. To move towards stability. Now you can clearly see this thing, that He24. So as soon as you lose the alpha particle, you are losing 4 nucleons. So as soon as you lose 4 nucleons, what happens? The A value decreases. As soon as you lose the 4 nucleons, A value decreases. And as soon as A value decreases, so R decreases. And when R decreases, what happens? When R decreases, this particular situation will reduce to something like this. Okay, it will reduce to something like this, and the nuclear force will again become dominating factor. So it will help in the stability. of the nucleus, in the existence of the nucleus. Okay. By emitting the alpha particle, the nucleus decreases its mass number A. To move towards stability. Okay. For alpha decay, the decay equation is, now for alpha decay, the decay equation is what? For alpha decay, the decay equation, so the decay equation is something like this. Okay. For alpha decay, the decay equation is something like this. X is what? X is symbol of element. X is what? X is the symbol of element. Z is what? It is atomic number. A is what? Atomic mass number. Okay. So one alpha particle emitted. One alpha particle emitted. So the protons will, two protons went into the alpha particle. Two protons went into alpha particle. So what happens? Number of protons in this reduced by 2 because 2 protons have gone in alpha particle. And total number of nucleons, that is total number of proton and neutron. So it has taken 4 nucleons with it. It has taken 4 nucleons with it. It has taken 4 nucleons with it. So initially A was the total number of nucleons. 4 nucleons have gone over here. 4 nucleons have gone over here. So finally A minus 4 nucleon will remain. Finally A minus 4 nucleon will remain. Okay. So parent nucleus gives daughter nucleus plus alpha particle. Okay. So the nucleus which is on the left hand side of the equation, the nucleus which is on the left hand side of the equation, it is what? It is parent nucleus. The nucleus which is on the right hand side of the equation, that is what? That is daughter nucleus. And alpha particle you already know. What is alpha particle? You already know. Okay. So due to alpha decay, what happens? Due to alpha decay, number of protons Z is decreased by 2. Due to alpha decay, this is what alpha decay. So number of proton is decreased by 2. Number of neutron is also decreased by 2. Let me tell you why number of neutron is decreasing by 2. Because helium 2 4. Okay. Let us look at this. What is the number of proton in alpha particle? What is the number of proton in alpha particle? It is 2. What is the number of neutron in alpha particle? 4 minus 2. What is the number of neutron in alpha particle? 4 minus 2, which is again equal to 2. So number of proton is also 2 in the alpha particle and number of neutron is also 2 in the alpha particle. So when an alpha particle is ejected, okay, when an alpha particle is ejected, what happens? When an alpha particle is ejected, then the number of protons, okay, the number of protons will also reduce by 2 because 2 protons will go from here to here, okay, and number of neutrons will also reduce by 2 because 2 neutrons will go from here to here, okay. So it will be the reduction will yield you this daughter nucleus. The reduction will yield you this particular daughter nucleus, okay. So number of proton Z is decreased by 2, number of neutron N is decreased by 2, mass number A is decreased by 4. Mass number A is decreased by 4. Now let us take an example, okay. So what is the example of alpha decay? So we have taken one example. This is what? This is bismuth. Okay, this is bismuth. And this is what? This is thallium. Okay. This is what? This is thallium. Okay. So the bismuth is converted to thallium. So number of protons 83. 2 protons went with alpha particle. 2 protons went with alpha particle. So final number of protons is 81. Final number of protons is 81. Now you know this very well. You know this very well that the identity of an element. The identity of an element. Identity means the identity of an atom. Okay. The identity of an atom will depend on number of protons. You already know this. You have learned the periodic table of elements in lower classes. You have already learned the periodic table of elements in lower classes. What happens there? What happens in the periodic table of elements? So in periodic table of elements, the elements are arranged. The elements are arranged in the increasing order of atomic numbers. In periodic table of elements, the elements are arranged in increasing order of atomic number. So atomic number is the identity of an atomic number. It is what? Atomic number is what? It is identity of an element, of an atom. Okay, identity of an atom means the atom is of which element? The atom is of which element? Okay, so this is decided by atomic number. So as soon as atomic number, it is denoted by symbol Z. So as soon as Z changes, identity of atom changes. Identity of atom changes. So what does it change then? Identity of atom changes. So what does it change? Identity of atom changes. So symbol changes. Okay, symbol changes. Symbol changes. Okay, so that's why when 2 protons were lost, lost out of 83, 2 protons were lost. So the element changed. It changed from bismuth to thallium. Now the identity of an element does not depend on its mass number. Okay, let me tell you one thing very frankly, that the identity of an atom, okay, the identity of an atom depends only on atomic number. The identity of an atom depends only on atomic number, does not on mass number. Okay, so the identity of an atom depends only on atomic number, it does not depend on mass number. Okay, so identity of an atom only depends on atomic number, it does not depend on mass number. So the bismuth atom has been changed to thallium atom. And upon alpha particle was removed, so 4 nucleons removed from here. Okay, this is total number of nucleons. So reduction in 4 nucleons. So 212 minus 4 equal to 208. So final atomic mass number is 208. Okay, so this is the nuclear equation. This is the nuclear reaction equation. Okay. This is the nuclear reaction equation. Now the Q value of the process onwards. Okay, now the Q value of the process onwards we will look in the next class. Okay, the Q value of the process onwards we will look it in the next class. Q value of the process onwards, this will be in the next class. All these things from here onwards will be in the next class. We will discuss it in the next class. So thank you very much. Please like, subscribe and share. Please do like the video. Please subscribe to our channel. Okay, and you can watch from the very first lecture if you want to understand everything very clearly. So thank you very much.